Friends, very good morning. We have studied about the dienes, preferably the conjugated dienes, its stability, its reactions, its rearrangement, and so on and so forth. And another important and unique feature of dienes is that it exists in two different conformations, or they have two conformers. What are conformers? These are the two different isomers that are possible due to the rotation across the carbon-carbon single bond. This conformation exists in alkanes. These conformations are these conformers, that is the isomers that are obtained by free rotation across the carbon-carbon double bonds are also called as rotamers, because that these are the isomers obtained by the rotation across a carbon-carbon single bond. The two interconvertible conformations are cis conformers or cis conformation. This is that it is cis to single bond. Here you see the two double bonds in butadiene are on the same side. The angle between the plane of this carbon-carbon double bond and the plane of this carbon-carbon double bond is 0 degree. Means both of the double bonds lie in the same plane. This is in the same plane as that of this carbon-carbon double bond. That's why the angle between the plane of this carbon-carbon double bond and the plane of this carbon-carbon double bond is 0 degree. This angle between the planes of the carbon is called as torsion angle. Here the torsion angle is 0 degrees. And there is another conformer that we call it as transconformers or transconformation. Here in this transconformation, the plane of this carbon is in one plane and this is in another plane. The angle between the plane of this carbon-carbon double bond and the plane of this carbon-carbon double bond is at 180 degrees. They are in the opposite plane. That's why the torsion angle is 180 degree. Here the two double bonds lie in the same plane. That's why torsion angle is 0 degree. The diene can exist both in cis conformation and also in trans conformation. Why this occurs? This is a carbon-carbon single bond, and because of this single bond, they are free to rotate. When they rotate, this carbon-carbon double bond rotate, and this also can rotate. And when they come in the same plane, that is the torsion angle is 0 degrees, then it is said to be that they are in cis conformation. Here this double bond is in one plane and this double bond is in the opposite plane. This occurs because of rotation across this carbon-carbon single bond. Hence, it is said to be in trans conformation. Because it exists in cis conformation and trans conformation, these are two are the rotamer, cis rotamer, and trans rotamer. Because of this, conjugated dienes in cis conformation, it exhibit a reaction. It can undergo cycloaddition reaction. The cis form of 1,3-butadiene can react with a alkene like ethene, and it undergo addition reaction followed by formation of cyclic products. That's why we call it as cycloaddition reaction. This cycloaddition reaction was first identified and explained by Diels and Alder. That's why it is named as Diels-Alder reaction. A butadiene in cis conformation reacts with an alkene to give a cycloaddition product. In the formation of this cycloaddition product, the electrons in this double bond, that preferably the pi electrons in this double bonds in butadiene and an alkene, moves in a cyclic manner. That's why we call it as electrocyclic reactions. Diels-Alder reaction is an electrocyclic reaction in which 1,3-butadiene reacts with ethene to give cycloaddition product. I'll take butadiene, 1,3-butadiene, and an ethene, and here this butadiene is a representative of diene, and this alkene is, you call it as dienophile. Electrophile. What is electrophile? Electron deficient species. That is electron loving species. Dienophile. Diene loving species is dienophile. This diene loving species reacts with dienes and it gives a cycloaddition product. The pi electrons between this 1 and 2 position moves towards the carbon of the alkene, and it has to maintain its tetravalency. That's why pi electrons here it moves towards this carbon of the double bond, and it has to maintain its valency. That's why pi electrons here moves to the next position. The electrons in the dienes and the dienophile, it moves in a cyclic form. This will move over here, this will move over in a form of a cycle. That's why we call it as electrocyclic reaction. What we will get? The bond over here has shifted and a bond is formed between this carbon and this carbon. That is the diene and the dienophile. And again the pi electrons is shifting towards here. That's why a bond is formed between the carbon of the dienophile and the carbon of the diene. And the pi electrons over here is moved and I have got a cyclohexene, and this is called as Diels-Alder adduct. In this reaction, in any reactions which you have come across in the organic chemistry, it forms an intermediate like a carbocation or a carbanion or a carbene or a free radical. In this Diels-Alder reaction, there is the shifting of the electrons in a cyclic form. That's why there is no intermediates formed. This is the unique reaction in which no reaction intermediates are formed, and that are electrocyclic reaction, and this is unique reaction exhibited by dienes, not by any other organic compounds. This is having a transition state where the electrons are moving from the diene carbon to the alkene carbon, and a partially carbon-carbon bond is formed. Here also partially carbon-carbon bond is formed and the pi electrons over here is shifting. In the transition state, the electrons have moved cyclically to form an stable product that is adduct, which we call it as Diels Alder adduct. This occurs because of the fact that the conjugated dienes exhibit in cis conformation and trans conformation. As the cis conformers, the two double bonds lie in the same plane and the torsion angle is 0 degrees. They are more nearer to that. The pi electrons nearer to it, they repel. When they repel, it moves to another conformer, trans conformer. Both cis and trans conformer, the energy difference is very less. That's why the conjugated dienes, that is the butadiene, can exist in cis form and also trans form. It is like God to us. God for Hindus is Ram. God for Muslims is Rahim. But Ram and Rahim are both gods. In which form the God exists? For Hindus, he exists in the form of Ram. For Muslims, he exists in the form of Rahim. But both Ram and Rahim are gods for human beings. Likewise, the dienes can exist in cis conformation and also trans conformation. And this cis conformer of the diene reacts with a dienophile to give Diels Alder adduct. This is the unique reaction, that is cycloaddition reaction, electrocyclic reaction, and this is exhibited by dienes, and we can deal this electrocyclic reactions in depth in the pericyclic reactions class that I have explained in other presentations. We are dealing in depth. The beauty of the electrocyclic reactions are that they are highly stereospecific in nature. That makes difference from the other reaction. In that presentation, we will deal in depth. Till then, have a nice day. Thank you.